Salamat sa Diyos sa isa na namang panibagong araw para matuto. Muli, ako si Teacher Royce at hayaan niyong gabayan ko kayo upang gawin nating ang math ay maging math dali lang. Simulan na natin. Ang pag-uusapan natin ngayong araw ay ang tungkol sa nature of roots of quadratic equations. Our main objective is for you to characterize the roots of a quadratic equation using the discriminant. Everyone, warm-up activity muna tayo. So you have 1 minute to answer this activity. Pakihanda ng inyong lapis, ballpen at papel. I will read now the direction. You're going to describe the roots of the following equations as letter A, real and distinct roots. Letter B, real and equal roots. And letter C, no real roots. So your timer starts now. Time's up. So let us now check your work. And here are the answers. For item number 1, the equation x squared plus 3x minus 28 equals 0 has letter A, real and distinct roots. Number 2, the equation 2x squared plus 20x plus 50 equals 0 has letter B, real and unequal roots. Number 3, the equation x squared minus 4x plus 11 equals 0 has letter C, no real roots. And number 4, the equation negative x squared plus 1/4 equals 0 has letter A, real and distinct roots. So sana nakuha nyo ang tamang sagot. Kung hindi naman, aalamin natin kung paano makukuha ang mga sagot na ito. Balik tanaw muna tayo. I know you are familiar with the standard form of the quadratic equation. It is given as ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a should not be equal to 0. I know you are also familiar with the quadratic formula. So it is given x is equal to the negative of b plus minus the square root of b squared minus 4ac all over 2a. So the quantity inside the radical sign, b squared minus 4ac, is called the discriminant. It is represented by a capital letter D. the discriminant d is equal to b squared minus 4ac. Ito ay ginagamit para to tell the types of roots the equation has. Now, look at the table to your right. If we're going to obtain the value of d or the discriminant of a certain quadratic equation, and we obtain a value d greater than 0, then the quadratic equation has real and distinct roots. So in case the value of d that we obtained is equal to 0, then the type of roots the quadratic equation has real and equal roots. And lastly, if we obtain a value of d which is less than 0, then the quadratic equation has no real roots. So let us proceed with the samples. Ito yung mga sagot natin kanina sa preliminary activities. Let us verify our answers. For item number 1, the equation x squared plus 3x minus 28 equals 0 has real and distinct roots. So since the equation is in the standard form of the quadratic equation, we can identify the value of a, b, and c. So here are the values. A is 1, b is 3, and c is equal to negative 128. So let us use the discriminant to verify if indeed the equation has real and distinct roots. So again, the discriminant is given the formula d is equal to b squared minus 4ac. By substitution, we will have d is equal to 3 squared minus the product of 4 times 1 times negative 28. So evaluating that, we will have 9 minus negative 112. So getting the difference, we will obtain d is equal to 121. So based from the value, we can conclude that the discriminant is greater than 0, and indeed the quadratic equation has real and distinct roots. To check further, let us compute for the roots of the given quadratic equation. Alamin natin kung ano ang mga roots ng given quadratic equation at mapatunayang ang mga ito ay real and distinct roots. So by using the quadratic formula, x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Let us substitute the values of a, b, and c. So we will have x is equal to the negative of 3 plus minus the square root of 121, which we obtained earlier, the value of the discriminant, all over 2 times 1. So extracting the square root of 121, we will obtain x equals negative 3 plus minus 11 all over 2. So let us compute for the roots of this equation. So writing separately, the first root is equal to negative 3 plus 11 over 2. The other one is x equals negative 3 minus 11 over 2. So we will get x is equal to 8 over 2. That is equal to 4. And the other root is x equals negative 14 over 2, which is equivalent to negative 7. So ayun, we have verified that indeed the given equation has real and distinct roots. Sana nasundan ang ating example. So we will proceed now to example number 2. The given equation 2x squared plus 20x plus 50 equals 0. This is also written in the standard form of the quadratic equation. Let us find the value of a, b, and c. From the given, we have a is equal to 2, b is equal to 20, and c is equal to 50. Ngayon, alamin natin kung talagang ang equation ay may real and equal roots. So here is the formula of the discriminant, and by substitution, we will have v is equal to 20 raised to 2 minus the product of 4 times 2 times 50. We will have 400 minus 400, and that is equal to 0. So from the table a while ago, if the discriminant is equal to 0, then the equation has real and distinct roots. Let us compute for the roots of this equation for further checking and verification. Again, by quadratic formula and by substitution, we will have x is equal to negative 20 plus minus the square root of 0 all over 2 times 2. We will have negative 20 plus minus 0 over 4. So writing the roots separately, we will have the first root, x is equal to the negative of 20 plus 0 all over 4, and the other root is x equals negative 20 minus 0 all over 4. We will obtain the first root is x equals negative 20 over 4, and that is equal to negative 5. The other root is x is equal to negative 20 over 4, and that is also equal to negative 5. So we have verified that the equation has real and equal roots. Subukan natin yung susunod. Example number 3. The equation x squared minus 4x plus 11 equals 0. Based from our answer a while ago, this equation has no real roots. So again, this equation is in standard form of the quadratic equation. Let us now get the value of a, b, and c. So we have a is 1, b is negative 4, and c is 11. Here is the formula for the discriminant, and by substitution, we have d is equal to negative 4 quantity square minus the product of 4 times 1 times 11. We will get d is equal to 16 minus 44, and that is equal to negative 28. Based from the table, if d is less than 0, then the equation has no real roots. So let us compute for the roots of the equation to verify. So the quadratic formula, and by substitution, we will have x is equal to negative of negative 4 plus minus the square root of negative 28 all over 2 times 1. So next, we will have x equals negative of negative 4 plus minus the square root of 4 times negative 7 all over 2. Negative 28 was factored such that one of its factor is a perfect square. Then we will have x equals 4 plus 2 square root of 7 all over 4, and x equals 4 minus 2 square root of 7 all over 4. Then finally, we will obtain the first root as x equals 1 plus 1 half the square root of 7, and x equals 1 minus 1 half square root of 7. So as we all know, the square root of a negative number is imaginary. So we have verified that the equation has no real roots. Now, the last example. The equation negative x squared plus 1/4 equals 0 has real and distinct roots. So this is written in the standard form. So let us get the value of a, b, and c. So we have a is equal to negative 1, b is 0, c is 1/4. By substitution in the discriminant, we have d is equal to 0 squared minus the product of 4 times negative 1 times 1/4. So we will have d is equal to 0 minus negative 1. And the difference is d equals 1. So 1 is greater than 0. Therefore, the discriminant is greater than 0 and the equation has real and distinct roots. So again, for the last time, let us compute for the roots to check and verify. By quadratic formula and by substitution, we have x is equal to negative of 0 plus minus the square root of 1 all over 2 times negative 1. We will have negative of 0 plus minus 1 all over negative 2. Writing the root separately, we have the first root, x is equal to 0 plus 1 all over negative 2, and the other one is x is equal to 0 minus 1 all over negative 2. So we will get x is equal to 1 over negative 2 or negative 1 half, and the other root is x equals 1 half. So we have verified that the equation has real and distinct roots. So sana nakatulong ako sa inyong lesson at naintindihan ang mga discussion natin. Lalo na sa pag-identify kung ang quadratic equation ay may real and distinct roots, real and equal roots, and no real roots. Maraming salamat sa panonood at pakikinig. Nawa ay natulungan ko kayo sa inyong lesson. Muli, maraming salamat at magkita-kita tayo sa susunod na video. Paalam!